Hello, welcome back to First Steps in Learning C#, brought to you by proto-pic and Railcon Systems. This is Lesson 4 and my name is Roy Fisher. Today I want to introduce you to some of the ways in which C# allows us to repeat statements and repeat actions over and over again. This lesson will also touch on some new ideas that will become very important as we progress. Here's a C# console program. I have a string which I've declared and initialized with the value greetings. At line 2, a console write line, which has this format string with 1 to 9 separate placeholders and 9 matching arguments. Each of these, S square bracket 0, 1, 2, 3, 4, 5, should be familiar to you. What this is doing is it's taking each of the characters, this list of characters that string is, and it is hopefully printing them out. The read line is just there so we can examine output on the screen. Here's the output on the screen. We can see that what I've done is take the word greetings, I've put a space inside between each character and put it out. Now that program may save me some money at Christmas time on cards, but perhaps it has a few flaws. One is the message always greetings. 2, it only works for 9-letter words. And 3, it's rather clumsy. Here's another attempt. Let's have a look at it. Well, this seems to be better. It allows input from the user. It must be between 2 and 9 letters. And it uses this if, else if, else if, else if, else construct that we saw last week. It is rather lengthy though. Let's just see if it actually works. And rather than run it, here's some runs what I did earlier. If you're wondering how I managed to get 11 console windows running in Visual Studio, then stop worrying. I used a composite here of Visual Studio and Paint.net. I'll let you examine the output if you like and the program, but can I just draw your attention to this part here? Namespace L4_Foreach. Yes, you probably guessed it. We're going to rewrite our program, but this time use a more elegant way by using a construct called a Foreach statement. Let's look at a new program. Here's the bones of our new program. We still have the type in your word, but we removed the restriction from 2 to 9 characters. We have the string with the read line, so we get user input. We have a console read line at the end, so we can see any output. The line with the Foreach statement starts with the keyword for each, followed by opening and closing round brackets. That's where some expression goes. And after the brackets, similar to the if of last day, we're allowed to do one thing. That one thing can be a semicolon, in other words an empty statement. It could be a single statement like write line. It could be a compound statement made up of many single statements but treated as one by putting them in braces. And I'll do that right here. Before we consider the expression that goes between these rounder brackets here, let's just recap on a string. We can think of a string as being an ordered sequence of characters. Sometimes we call this a collection of characters, but it's an ordered collection. We often refer to this as an array. There are different words and terms, but essentially it's an ordered list or array. So what we want to do is we want to iterate. Start at the first character, go to the next character, and then to the last character. So we're going to look at each character in this string. And each character will have a type char. And each char needs a name, so I'll call that ch. And then the keyword in. And then the list or array that I'm iterating over, which of course will be s. So I'll read that as, starting at the first character, just go round and round and round until you've got to the end of the word. Let's check this and run. I'll type in hello, press enter. It's now waiting for my read line. Press my at the end, press my read line, and it worked to a fashion. It's just that we haven't told it what to do in there yet. Let's fix that right now. Here's the payload. Console.write, one single value represented by this format specifier, and then ch. Let's repeat our exercise. Type in your word. I'll type in greetings. And there we go. We have the output. Here's a few more. We'll type in nothing at all. Enter. Enter to get rid of the last read line. No errors. Fine. Notice that I've used the console.write method here rather than our console write line. I'll run this program, but while I do that, visualize what will happen. Hopefully you guessed correctly. Yes, putting the write by itself prevents new lines being put between characters. But you probably knew that. I've replaced the writeLine method of the console class with the write method of the console class. And now I'm going to look at another way of having an array or list of items. And I'm going to do char, an array of char. And I need an open square bracket, a close square bracket. That tells the C# compiler that I'm going to make an array of characters. Being empty tells it I don't know how long that array is going to be, i.e. how many members it's got. I need a name for this character array, so I'll call it char array. Why not? Equals. And I'm going to give it a list. To do that, I open a curly brace, close a curly brace, and put in a semicolon. Of course, there's nothing inside the curly braces, so I'm going to give it one member, one element. And double quotes, G, double quotes. Let's see if this works. It doesn't like that. And if I hover my mouse, it tells me it cannot implicitly convert type string to char, because double quotes is used for strings, but for chars we need single quotes. If you're like me, you'll make that mistake many, many times in your C# career. That's my greetings array set up now. I'll adjust the program. I'll comment out, for example, string, and the type in your word, and I'll have to change this Foreach expression. S, of course, no longer exists. What I now have is char array, is my collection or my array. So char's okay, that's fine, the same type. If we run this program, we should hopefully see what we saw before, or what we'd expect. So far, so good. We'll replace our character array, this time with a string array. So I'll comment out this line, and I'll put in a line I prepared earlier. Same syntax, or similar syntax, the type, string, rather than a char, the empty square brackets, the name, S, curly braces around what goes inside the array, and then a list of items separated by commas. Notice, of course, I need double quotes because it's a string, and I need to change this as well. I better change this from char, because I'm now reading strings, so I'm going to iterate, count from the start of the array, the word hello, to the next word, world, and then so on, if there was any so on. So I put in string. I think I better make this more sensible rather than ch. We'll call it str. And char array does not exist anymore. We commented it out. So I'll put in s and change that. str. All squiggles gone. I've got array, a string array of 2 members, the 0th and the 1st. When we run, it says hello world. It puts them back together again. In day-to-day life, we're quite used to seeing lists of sorted words and whatever. For example, a sentence. A sentence could be something along the lines of that. String sentence equals hello world and greetings, is what it says. Let's comment out that string s for the moment. Put in the word sentence in replacement of s, and see if that works. Doesn't look very good. What I'm wanting to do is somehow split that sentence up so it says hello, world and greetings, in other words, into its constituent 4 ordered words. Ain't playing yet. We could certainly program in the possibility of looking at a sentence and breaking it into its ordered constituent words, but why bother? C-sharp's got there ahead of us. Sentence is a string, and if I put a dot after the name, I can see it conveniently comes to a place called split, which I'll do. I'll put in brackets, it's a method. Sentence.split, run. Can't see any difference at the moment, but that's because I need something in here to make it visible. And I'll put in a pile of stars and a percentage sign for dramatic effect. See what's happened is that clearly the loop has gone round and round, at least we think it has, and it's put the word followed by this interesting information. It's worked, but we'll check that further. We'll check that by putting a breakpoint. Remember to click in that console right line, or the console right. Run. When I run, we stop here. Check my str to start with, hover over it, hello, then I'll press the step over, F10. You can see it's cycling through the words one at a time. So that confirms this repetitive nature of the for each loop. One final bit, greetings. I'll stop it there. Before I continue, I think it's important to realize is that C# by itself is actually quite a skinny language. There's not a lot to it. Well, there's maybe 80 or so keywords and a few other bits and pieces. Modern programming languages get their power not from the language itself. The language is just the enabler. But it gets it from the vast range of classes and objects that are provided by the writers of compilers and people like Microsoft with their net framework. That's where split comes from. It's not part of the C language. It's a method of the string type. I've removed the breakpoint and copied this console.write line and put it just below here, just below these closing braces of the for each statement. Notice we have a red squiggle. It says the name str does not exist in the current context. That's very odd. We've used str before. That line is exactly the same as it was when we copied it. Line 21 and 23 are both the same. But whereas str is recognized here, it's not recognized just another line later. And the reason for that is to do with something which gives beginners and more advanced programmers as well a great deal of problems at times. It's something called scope. Because str has not been defined anywhere except here in this line, then it's not recognized outside of this construct. That means from here to here. As soon as we leave that closing brace, str is said to be out of scope. It's invisible. This sounds like a problem, and it can cause issues, but the benefits are far greater than any downside. It means that we can use variables as leanly as possible. For example, we don't have to put a variable up here and then 50 lines later refer to it. If we only want to use it for one small part of our program, then we can make it go out of scope. In that way, we can save on memory, or at least the C compiler and the C runtime system, or C#, will help us do that. Because the scope or visibility of str is only within these confines from the for each to the end brace, what happens if we want to actually see what the last value of str was? And the answer is we have to create another variable if we want to read it outside. We have to get a variable that has scope that's available to this console.write and then capture the value of str. We'll do that. We'll create a new variable called s2, just because I've got an imagination, and we'll attempt to put it somewhere. What do you think would happen if we put it here? String s2, semicolon, followed by the line s2 equals str, semicolon. Clearly, we still have an issue to resolve. Str was as before, S2 seems okay, so it looks like we can declare a variable inside this compound statement, these enclosing braces. Of course, str we already know doesn't exist, so let's put S2 in there. Doesn't like that either. Okay, let's just check. Same problem, because we've fallen out of scope. It's not visible because it's been declared in here. You can't use it outside this statement or this group of statements. I need to put this elsewhere. So I'm going to remove this and put it before we get in. String S2, and I'll get rid of that extraneous new line. Okay. And it still gives me a problem here. It says it's unassigned. Now that's an odd one. It says it's unassigned, but it has been given a value. It's been given a value inside here. But in C#, I'm using this variable. I'm trying to give it a value. And in C#, I'm not allowed to use variables unless I've actually given them a value. So I'm going to give this an initial starting value. We'll call it start. My imagination at work again. And now the problem seems to disappear. So let's run. And it says hello world and greetings. Greetings is repeated. Good. So in other words, as we'd expect, the last word of the sentence, greetings, was repeated with this line. And of course it's not a right line, so therefore it just follows on from all the other rights. Notice that the initial value we gave S2 to start is never used in this particular program, but C# insisted that we have a value before we went into here. And that's all to do with parts of scope and the rules of C#. If it all seems a bit odd, well, eventually you get to accept it. And I want to move on to looking at other types of arrays. I want to look at arrays of numbers so we can do some arithmetic. Here's the program that we're going to use to look at this new type of array, this number array. I've kept the other lines here, or some other lines, so you can compare them, but ignore all the commented lines for the moment. Here I have my declaration and my initialization of the array of integers called mol. Don't know what that means, might become clear later. Equals open brace, close brace, 12, 14, 7, 9, seems fine to me, at least the numbers, the whole numbers. For each, now of course I've changed this, each integer, so that should hopefully be 12, 14, 7, 9 in mol, which is my array, console.writeLine, the value of I, and then readline. I think you should be able to predict what that will look like. 12, 14, 7, 9. Exactly in the same order. No surprises there. Let's now imagine that we wanted to add up all these numbers in this array. We want that result printed outside this for each statement. So we want the arithmetic done inside here, the for each, and we want the answer written outside. What we do know is that to take the answer of anything that's discovered in here, we need to have a variable that's been created outside of the scope of this for each statement. And I've already created a variable, which I'll get by removing the comment, and we'll call it sum. And I've got a line here which will show the output of the sum. At the moment we have an issue that says it's not been assigned a value. Well, we'll come to that in a moment. But I'm going to put a wee bit of arithmetic just inside here. And it's going to be very simple. Sum equals sum plus I. Now when I press the semicolon, have a wee think and decide what you'll see. Well, got that red squiggle that's moving up the way. It's telling me it's unassigned because, as I mentioned earlier, you cannot use a variable unless it has been given a value. Here, int sum has got no value, set to have a null. We're going to give it a starting value, and we'll make that equal to 0. And that sounds sensible. Before I start adding up numbers, I'm presuming that I'm starting at 0. Then the numbers will change that 0 to something else. So that seems okay. That seems okay. Sum equals sum plus I. No issues. Let's just run and see what we get. And we get the 12, 14, 7, 9 from here. That's all done there. And then we get the number 42. Okay. So the sum equals 42. And that equals the sum of them all. In an earlier lesson, we discussed the use of the plus plus operator, as in x plus plus or plus plus x, and said it was a very efficient substitute and a very convenient way of writing x equals x plus 1, z equals z plus 1. In fact, incrementing, or we can use the minus minus to decrement things. And so common as this is that C# programmers and C programmers before them have had this facility. Well, we also have a shorthand way of writing sum equals sum plus I, plus equals. That's equivalent to sum equals sum plus whatever I is. We'll run that just to prove it. Exactly the same as before. We can even apply the minus in here. Just visualize for a minute what that might be. Run. And the answer is minus 42. But that's a very, very powerful way of expressing something, and you'll see it written lots of times. It also tends to make your programs much faster. If you're new to programming, this sum equals sum plus 1 and sum equals sum minus 1 may be confusing. If that's the case, hang on for a few minutes after this lesson is finished. Next week, we will be looking at a more powerful or much more used construct for repetition and iteration called the for statement. We'll also learn how to tidy up our code and get it into smaller, easily managed chunks. If you're happy with sum equals sum plus I, then goodbye. Those of you who are not too sure, I will take a few minutes to explain. Still here. Okay. I've stripped this program down to its bare essentials. I've got my declaration and my initialization setting sum to 0. I've got my array there, my int array, mol. I've iterated through with my for each statement. I've got this payload in here and then the output there. And I've rewritten the sum equals sum plus I. Oh, I've got 2 semicolons. Won't do any harm. In fact, I could have a dozen. In fact, let's put some more in. I only need 1, but let's be fun about it. It's after class anyway. So let's take the start of this. This for each statement will take each of these values in this array one at a time. First of all 12, then 14, then 7, then 9. So that we go 1, 2, 3, 4 times around this loop to add up the sum. And initially the sum is 0. So let's put a breakpoint in here just to examine the value. And we'll do it just there. I've run the program and, true to form, the breakpoint has been hit for the first time. Before I start looking at the values though, let's just clarify what's going to happen here. The first time we get this for each loop, the value of I is retrieved and is 12. So that line, sum equals sum plus I, basically says this. Let the new value of sum, here, equal the old value of sum, which should have been 0. So that's 0, and the computer tucks that away somewhere. And the current value of I. Well, I is 12. So that should be the old value, 0 plus 12 is 12. So that value of 12 should get put into sum and replace the old value of 0. Let's just confirm that by hovering. Sum is 12. Our thinking is correct. I'm going to continue with our stepping, and I'm going to ignore the console. So the value of I is the second time round. We think it should be the second value. That's the 0th, the 1th, the 2th, the 3rd, if I can use those terms. Remember, arrays start at 0 in C and C# and many other languages. I is 14. So what this sum should do is new value equals old value plus I. The old value, well, it used to be 0. It then became 12, so that's the new old value. 12 plus the value of I is 14, is 26. So that value of 26 should get put into here. So the new value of sum should become 26. At the moment, it's still 12. It hasn't yet executed. I'll then step the next line, It's now performed this calculation, and the sum is now 26 as predicted. We do that again, perhaps you can see where we're coming from, and into the third time of the loop, that's the 1 second number, second index, which is 7. That value is 7, should then get added to the previous sum. Currently it's 26, 26 and 7, 33. So once I get through that statement, sum should be equal to 33, which it is. I think possibly now you can start to see how this sum equals sum plus I makes sense. I'm now on the fourth and final iteration, and that should give me a value of 9. At the moment it's still 7. It hasn't yet executed this line, so it has the old value. But I run it once more, or step once more, and I is now 9. So before we had sum was 33 plus 9, sum, that should now become 42. And that's where the name mol comes from, just to let you know. That's the meaning of life if you've ever seen the Hitchhiker's Guide to the Galaxy series or read the books. If not, I warmly recommend them. Anyway, hope they helped. Goodbye.